Hi, this is your host Subhil Bhartia, and we are here in Paris at the LF Energy Summit. And today we have with us Tony Xiang, TSC Chair of Power Grid Model Project at LF Energy and Lead Scientific Engineer at Alliander. Tony, it's great to have you on the show.
Hi, nice to meet you.
And today we are going to talk about Power Grid Model Project. Talk a bit about the origin of the project, how and where the project started.
Well, I'm very eager to talk about it. So around 5 years ago or something like that, 2018, we were at Alliander looking for a good power grid calculation software. So that means we want to do a lot of grid calculations based on our future needs. One of the examples is that we want to simulate what are the growth of electrical vehicles in the coming 50 years. What would be the impact on our electrical grid? We were looking for some calculation tools. Unfortunately, we could not find appropriate tools either from commercially or from open source world. So at that moment, we decided, okay, let's build our in-house solution, and we call it Power Grid Model.
You mentioned, kind of when you talked about EV, what we are seeing is that the whole kind of ecosystem is evolving. In early days, power flew from, distributors to our homes, but now the way we are consuming power is also changing. How we are consuming is changing. And we are also kind of becoming producers with the solar roofs and batteries at our home as well. So talk about it, that what does this change, the whole ecosystem means for companies like Alliander as you talk about this project, but it goes beyond the project.
That's a very good question, actually. So when we see the traditional way of electrical power system, especially distribution system, it's always a top-down approach. So you have the power feeding from the big generator through the high voltage line to medium voltage, to low voltage, and to our end customer in your house, at your house and my house. And also, the pattern of the usage is very regular. So, if you look at sum up of 10,000 people in a district, you will expect that there is a evening peak at 8 o'clock to 11 o'clock. The usage is high. Of course, somewhere in the middle of the night, like 2 o'clock in the night, there will be almost no usage. So that's pretty predictable. Once we change the pattern, so we have more electrical vehicles, we have solar panels, we have more like heat pumps, the behavior becomes more unpredictable and also more diversified. That means from our utilities perspective, we have to do a lot of more scenario analysis. Previously, we only do like a high load, low load. So what is the peak? What is the low end of your consumption? That's it. Now we need to simulate the whole year profile, even with multiple scenarios. So for 1 year, we simulate 100 random scenarios to see if all these kind of combinations actually satisfies our grid capacity requirements. And in order to do that, you have to execute power calculations much more times than what we were doing before. So I'm not talking about calculate one or twice or 10, even 10, hundreds of calculations. We are talking about millions, if not billions of calculations for a single analysis.
What was the reason behind putting it, releasing it as open source? Was the reason that you also felt that there are other, companies that can either leverage from this project or, they can also help make the project better? So what was the reason behind open sourcing it?
As you probably know, the project began as an inner source project. So that means everybody in the company can use the library. Everybody in the company can contribute to the library. And we were somewhere in 2021 in the phase that we have 10, 12 internal customers of our products inside the company for many various usage applications, which is very nice. And it turns out very quickly that all other options in the market are not as preferable as our model, because we can solve the pain point of the solutions which were in the market at that time. And then we think if this is useful for us, our colleagues at other DSOs, distribution system operators, they might face the similar challenges. They might also be a scramble. They had to say, hey, what is a good calculations library in the market? And I would guess they also could not find one, or they also would have to build their own software. Of course, that's not an efficient way to do it. At that moment, we were thinking, okay, maybe it's time to consider it to make it open source. and then we make the step to make the open source, and then also talk to other DSOs, distribution system operators, also other universities, research institutes to see what are the interests of them.
And now project is hosted by LF Energy. What kind of community is there? How many DSOs or other players are involved with the project today?
So we have now, currently, besides Alliander, we have two major DSOs from Netherlands. They are both also trying to implement our library into their production environment to run several scenario calculations, long-term planning, and so forth. We also have many PhDs, master students at the universities. They use our project as one of the calculation core for their research.
Since, as you said, that the project was already being used internally, which means that it is, in production. But if I ask you as a general question, how mature is this project? Is this ready for production? Of course, the answer is obvious, but still.
Let me put it this way. This is a production grade project, and it is used by also very many critical company critical process inside Alliander. So we actually, a lot of people at Alliander, they actually trust and rely on the performance and the validity of the library.
When we look at a lot of these projects, Linux kernel is a good example. Kubernetes is an example where the project was created to solve a specific problem for a specific person or company. But when you put in open source, a lot of folks come and start using it in a way that you did not think. What do you see the scope of this project? Can you go beyond the problem it was solving for Alliander? Or you see that there are a lot of other problems that can be solved with this project?
What you just said is actually happening at this very moment as we speak. So there are already feature requests and also a recommendation say, hey, can you add this feature, can you add that feature, which actually has nothing or very little to do with Alliander, but it can benefit on the whole community. So what we see it is about prioritization. So we don't blindly say this is out of scope, this is in scope. We always look at the community, what the community wants. And the community means both internal customers, that of course will be our priority, but also external interest. Like some TSOs, they are also interested to asking for integrate more transmission grid related functions, which might have less value for us, but if it can benefit the whole community, we might still consider to do it either by ourselves or encourage other people to contribute to it.
And I think the best thing with open source is that, hey, if you want this change, come and contribute. That's what the community is all about, right? Yeah. Everybody comes and get involved. Can you talk a bit about, of course, it's a mature project, it's in production, but what are the next steps for the project where you're like, hey, these are the things that we are working on, or this is the problem that we are going to solve with this project?
We actually have a good so-called community-driven development cycle. That means we have a meetup, which is organized half a year. And as a matter of fact, next week will be the next meetup. And in the meetup, we gather all the internal, external stakeholders. We try to understand what their needs, what their feature requests, what is the wishes. After that, we make the roadmap for the coming half year to make it say, okay, these are what has been asked from the community. Let's prioritize based on the interest of both internal and external people. And we do this in a cyclic way. So next time will be somewhere in the winter this year, then we do it again to hear again the feedback from the community.
If you look at not just LF Energy Foundation, but if you look at the sector, Europe is kind of, some of these companies, Alliander, RT, and a lot of companies, they're like pioneer, but this is not a problem is specific to Europe. We have to look at, of course, a North American company, so Fair Linux, they are also one of the sponsors. There a lot of work is going on, but this is a global problem. Asia, China, India, Africa, North America, South America. So talk about how do you see that LF Energy, and these projects can help a global ecosystem, not just something specific to a region.
Yeah, that's a very challenging task, to be honest. One of the main characteristics about the distribution grid is that there is no typical characteristic of distribution grid. So distribution grid system in general varies dramatically between regions, between the countries, and of course also between the continents. I also regularly talk to colleagues from America, US DSOs. They have somehow a complete different design of the grid, completely different design of the whole operating system of the distribution grid. So theoretically, it would be possible, but this project can benefit also Asia or American DSOs. In practically, I have to be honest that I would foresee major revisions and major function addition to make it possible.
As you're talking about, when it comes to feature, that a lot of folks are showing interest, and the best way to leverage or benefit from open source is by becoming a contributor, right? Come if you want a code, contribute. So if I ask you, if you look at this project, who do you think are ideal candidates to get involved with this project, to grow the community? And second part of the question would be that if somebody is interested in particular, what is the right approach?
Naturally, we are a Dutch DSO or European DSO, so I would think that the parties who most probably would be interested in this project are other European DSOs, distribution system operators, and the problem we are facing, I would guess they will facing too. So that's I think the most probable interested parties. A big group of people who might be interested is the researchers, either PhD students or master students. When they are working on their research on energy in the energy sector, they might use basic grid calculation tools, and also especially when you are doing machine learning related research, you need to also calculate the grids a large number of times, which our project can provide needed performance for that. And for the people who are willing to start with this project, who are willing to try it, I would suggest they go to our repository, and we have a very nice onboarding workshop repository, which shows nice examples of how do you use it, how do you prepare data, how should you interpret the results, and also with some nice assignments. So actually you can do the assignment one by one to see, hey, I want to do this, I want to do that, and then of course there are also solutions provided.
When we look at this project now, it's mostly about calculations. Can you also talk about if there is any scope or role? Because these days we all talk about generative AI, chat GTP and all those things. What is the scope of AI in this project?
So there are actually two parts which can be relevant for machine learning or AI in general. The first part is actually the first part is already being applied by many projects. So when you apply certain AI machine learning algorithms, usually the data set is extremely big. You have to calculate the grid a lot of times. That's when our project can contribute, so it can be used in a way that you, as a backend calculation core, you produce the training set or the test set for the AI to further proceed. That's the first use case. It's very concrete. It is being used by many research projects at this moment for this purpose. The other side, when you look at it, is the algorithm itself. So we have now the calculation algorithm, which is deterministic. We could think about to actually implement some AI machine learning related algorithms in the calculation core itself, so people can benefit from the power of machine learning. How that exactly will play out, that we have to try it one by one. We do have now also collaborations with some research program to look at the possibilities, and I'm very looking forward to that will come out.
Tony, thank you so much for sitting down with me. Of course, talk about this project and also the scope of the project, also the community. Thank you so much for all those insights, and I would love to chat with you again whenever there is an update of this project. Thank you.
It's my pleasure.